Hello everyone, I am Samuel Atta. This is Turning Points Tutorials, and we are back to mathematics class once again. Before now, we have been considering the topic logarithm. We started with the simplification in logarithm, and we took some vital questions. We saw the formulas guiding us in the laws of logarithm, and I'm going to tell you something like this. I said that that every logarithm to its own base is 1, and that log 1 to any base is 0. Alright? Then we said that when the logarithm has a power, it goes out to multiply the logarithm to give you 2 log a. So we said all of this, and then we said when you are adding logarithm, like you have log a plus log b, if you are adding logarithm, you multiply, that gives you log ab. If you are in the previous class, you know we have dealt with all of these. So I'm taking some maybe a little bit advanced questions, and we'll make progress in this aspect. So I have the first question on board already. Go with me and let's see this. How do you simplify a question like this? Now it said log 5 over 8 just base 10 minus 1 over 2 log 25 over 81 base 10 plus log 2400 over 27 base 10. The question is not well arranged. The reason is this, that we see that the minus sign came before the plus sign. So what do? Quickly arrange it. You have your workings like this. I will take this particular question, the particular portion of the expression, 5 over 8 base 10. This is a minus sign, so I'm going to leave the minus sign. Let me take the plus sign first. Plus log 2400 over 27 base 10. Then you have minus. Now you understand that the coefficient should go back as what? As a power. So 1 over 2 is going back as a power, as log 225 over 81 raised to the power 1 over 2, which is the same thing as the square root of 25 over 81. Alright, so at this junction we can express that to become what? Log 5 over 8 base 10 plus log 2400 over 27 base 10 minus, what is square root of 25? Square root of 25 is 5. Square root of 81 is 9. Okay, this is what you have now. So now everything is mind you, is base 10, is base 10. Okay, so everything is balanced now. At this junction, you just take one of the logarithm. Because you are adding here, you multiply. Then because you are subtracting, you divide by the 5 over 9 here. So when this multiplied is the answer divided by this. So let's just go down. So at the end of the day, you have log 10. Just log 10. Because all of these things now, they're all these logarithm now, they're the same base. Okay? So open the bracket, say 5 all over 8. Now this is what the plus sign, that's times 2400 all over 27. The minus sign, we say divide by 5 all over 9. Close the bracket. So at this junction, what do? You say log 10, open the bracket, 5 over 8. Okay, multiplied by 2400 over 27. This division sign changes to multiplication, and of course, as an effect, the 9 goes up, 5 comes down. Of course, this is the primary school principle. Okay, now we have log 10, open the brackets. Then you can do your division outside so that you don't soil your working. So that's 5 over 8 multiplied by 2400 over 81 times 5 all over 9. Okay, that's okay for now. Sorry, that's 9 over 5 please. Thank you for that. Let's look at this solving now. So now 9 here 1, 9 is what? That is 9. So 5 here will go this 5. Is that okay? So 8 here now is 1. 8 here is what? 8 here is 3. That makes 300. Bring it for the 0. Now we take this value. This is supposed to be 27. I'm making a mistake here. This is 27. This is 27. Right? This is 27. So please, let's take it over again. Very important. This is 5 over 8 times 2400 all over 27 times 9 over 5. Okay, we go. 5 up, take 5 down. 9 here up, go with 9 here 3 times. Okay, then 8 here down, go with 24 up. 3 times, bring forward the 0, gives you 300. 3 here down, we go with 1 3 here, mix 1, bring forward the 0, now you have 100. Please look at it carefully. 5 goes 5, 9 here, 1, 9 to 27, 3. 8 here, 1, 8 to 24 is 3. 3 cancel, this 3, it gets 100. So at the end of the day, everything remains as 100. But you were taught in your JSS class that 100 can be placed in index form. And what is the index of 100? That's 10 raised to the power to second degree, 10 raised to the power 2, base 10. Then at this junction, we apply the law of logarithm, which says that the power of logarithm goes back to multiply logarithm to give you 2 log 10 base 10. And of course, you know that every log into its own base is 1. Log 10 base 10 is 1. You get 2 times 1, and the answer is 2. Now, if this is well understood, you can still rewind this video and go over again if you don't understand my explanation. I want to take you to the next question before us on the board. Now, check this question. It's as simple as it is. Question number 2. Now, number 2, we want to simplify. Log 0.001 base 10. Okay, some students have problem with decimal, but this shouldn't be a problem. Okay, let me help you in a few seconds. 0.02 as miss sound like this can be converted to a fraction. What you do is on the line under decimal points you put 1. Okay, under 0 put 0, under 2 put 0. Removing this decimal point, removing the 0, you have 2 over 100. So this is how you can convert this now. So 0.001 over 1 under decimal point. You put 0 here, 0 here, 0 here. Now these zeros are not significant figures, so you wipe all the zeros away. You have 1 over 1000. Okay, so this thing can be written as logarithm 1 all over 1000 base 10. In other words, how can you write this now? Don't forget that 1 over 10 is same as 10 raised to the power of minus 1. So that means this is actually logarithm what? 1000 raised to the power of minus 1 base 10. Now, if you have 10 raised to the power of minus 1, and this 1000 itself means in index form 10 raised to the power of 3, and if you close the bracket, minus 1 is outside. Okay? Now, 10 raised to the power of minus 3, what do you have? Okay? You have logarithm 10 raised to the power of minus 3. Okay, base 10. Then what do you have now? Then minus 3, we go back to multiply the logarithm. That gives you what? Minus 3 logarithm 10 raised to the power 10 base 10. So, and 10 base 10 is already 1. So you have minus 3 multiply 1. You end it with what? Minus 3. So from here, what we have? We have this answer kept here is actually not we're supposed to have 3 here. So now from what we see, check this question, look at it carefully. It's following the format. Okay, from this we converted to a fraction. From this fraction we got this, and 1000 is 10 raised to the power of 3. 3 multiply minus 1 gives you minus 3, and 3 goes back to multiply logarithm, and 10 is 10 is 1, multiply minus 3 gives you minus 3. This is the second question. Now I would like to use this part of the board for the third question. Now what we have here, we're having a particular question here. That's a 2, question number 3, 2 logarithm 2 all over 5 base 5 plus logarithm 9 base 5 minus logarithm 72 over 125 base 5 plus logarithm 10 base 5. Okay, now from what you have gathered so far, it will be nice, and you know quite well that it will be nice for you to bring back this 2 as a power, and then arrange all the positive logarithm before the negative logarithm here. So if you carry this as a power, you have this. Carry as a power, you have logarithm 2 all over 5 raised to the power of 2 base 5 plus, taking this now, logarithm 9 base 5. Now, at this junction, it will be nice for you not to bother yourself with minus sign. So just to arrange your work properly. So take the minus sign, then you take positive sign here. So as plus logarithm 10 base 5 minus logarithm 72 over 125 base 5. At this junction, we are good to go. Now all in base 5, meaning that this value multiplies this value, divided by this value. Okay? So shall we? Now you can expand this. Let's expand this out. So let's expand this out to get when this power outside plus 2 over 5 is in the bracket, so the 2 will be affected. This 2 inside is affected by the power, and the 5 is affected by the power also. So 2 raised to the power 2 gives you 4, and 5 raised to the power 2 gives you 25. Okay, that's 5 times 5, 25. Base 5 plus logarithm 9 base 5 plus logarithm 10 base 5 minus log 72 over 125 base 5. It's okay. At this junction, I think we can go straight now. So let us take 1 of the logarithm base 5, open the bracket, and then do your multiplication now. This is the plus sign, so this multiplies this. Then it's the plus sign multiplies this. It's a minus sign divided by this. So what do you say? You say 4 all over 25. Okay, now multiplies by 9 all over 1. Okay, times what again? 10 all over 1. Okay, now minus sign says divide by 72 all over 125. So let's see if we can change division to times and do our inversion. That's what logarithm 5, open the bracket, 4 all over 25 multiply 9 all over 1 multiplies 10 all over 1 times, go up and down inside 125 all over what? 72. It's okay. At the junction now we can help ourselves quickly. 25 year 1. 25 can go into 125, of course. That's actually 5 times. Because 25 into 100 is 4. So into 25, 125 is 5 times. Alright. So let's see what we can do now. I think from here we have 3 can enter into 9 theory. Permission to do it in the rough way, please. Permission to do the rough way. So 3 into 9 is 3. 3 into 72 is so 3 into 7 now is actually how many times? 2 times. Into 12 now is 4. 4 can go into this 24. So 4 year 1. 4 into this is 4 into this give you what? Is 6. That's 4 times 6, 26. 3 can go into this now quickly. Let's see. So 3 year 1, and then 3 into 6. How many times? 2 times. That's not all. There's 10 up, there's 2 down. So 2 year 1 and 2 into 10 is what? Is 5. Now we have 5 up. We have 5 up. So they multiply to give you 25. So all you have at the end of the day is 25 base 5. Then you know that 25 can be placed in index form, which is actually 5 raised to the power of 2, all in base 5. Okay? And then 2 goes to multiply the logarithm. What do you have? That's 2 coming back, 2 coming back. That's 2 the logarithm, 5 base 5. And you know that every logarithm to its own base is 1. We're going to rest the case by 2 times 1. That makes 2. So you can see that the answer is correct here, which is 2 on the board. Alright, now before we shift our ground into something else in logarithm, let's try to attempt this question number 4. I believe by this time I should wipe this off. So here we have the word simplify. Simplify the question. It says logarithm 0.04 base 10 plus the logarithm 0.25 base 10 all over what? all over the logarithm 100 in base 5 minus the logarithm 4 in base 5. Okay, can we just quickly start? Looking at the numerator, you see that logarithm, the base is the same, and then we'll have the logarithm there. Then denominator has base 5, okay? So touch the, we can do it in a straight way. We can just work on this, and this long line, we can bring up division in an horizontal manner, in a way like this. Like log 0.04 base 10 plus logarithm 0.25 in base 10. I could decide to just decide to close this logarithm. This line of logarithm, I can just make it this way as a straight division, and then I will just have logarithm 100. Okay, sorry, pardon, logarithm 100 minus logarithm 4 is 5. I think it's okay like this. Okay, so with this now we can start the calculation. Right, but then we have some decimals to deal with, right? So let's touch decimals. Of course, this I've told you before how to change it. Let me just show it again. Now let's show it again. This is over 1, that's 0, 0. So move this now. You see you have 4 over 100. It's okay. So from here we have this now. We have logarithm 4 all over 400 is 10. Okay, plus logarithm 25 all over 100 base 10. Okay, then divided by logarithm 100 base 5 minus logarithm 4 base 5. Okay, alright, I think we can help ourselves here. Okay, let's see what we can do. When this multiplies this and this divided by this, let's see what we can do. So let's go now. We have logarithm 10, open the bracket, this times is, okay, what do we do? Let's work out some things quickly. We're going to have words 4 over 100 multiplies 25 all over 100, close the bracket. It's okay like this because I'm adding, so I multiply the two logarithm. Okay, divided by, having logarithm here, that's 100 divided by 4 base 5. It's okay like this. You can close the bracket. Okay, now with this, now we can make progress. Please, can we just touch it somewhere? Let's say 4 by 100 times 25 over 100. 25 here 1, 25 here is 4. 4 here 1, 4 here is 1. So at the end of the day, you have 1 over 100. And 1 over 100 is same as 100 minus 1. And 100 raised to power minus 1 is same thing as 10 raised to power minus 2. Because the 100 itself is 10 raised to power 2, which will be in a bracket. This 100 is simply minus 1. When 2 multiplies this, you get to minus 2. So everything here will make 10 raised to power minus 2. So get it right. So 10 raised to power minus 2 is the correct answer to give now. So log 10 raised to power minus 2 base 10 is what you have here, right? Divided by, what do you have here now? This 100 over 4. Now look at this now. When 2 go into this is 50, 2 here is 2 here 1, here is 25. Okay, so everything here is now 25. So we have logarithm 25 base 5. Okay, then we are going to look at this properly. Now, what do we have here at the end of the day? You see that you can put this in index form, alright? So you get log 10 raised to the power minus 2 base 10 divided by log 5 raised to the power 2 base 10. So what do you want to say now? Now let the power goes multiply the logarithm. This one go back. What do you have? What do you have at the end of the day? So minus 2 come back. That gives you minus 2 log 10 base 10 divided by, this goes back. You have 2 logarithm 5 base 10. It's okay. So this is already 1 log 10 base 10 is 1. This is already okay, I think I omitted that I added my wrong base. This I was supposed to put base 5 here. I believe you saw that. Okay, thank you. If you saw that, this is actually base 5. Follow me through. All are base 5, base 5, base 5. So I should do base 5, base 5, base 5 here. Is that okay? Alright. So at the end of the day, what do you have? You have minus 2. This is already 1 times 1, that's minus 2. Divided by what? 2. So, and when minus 2 divides 2, you should get minus 1. What I'm trying to say is minus 2 over 2 is minus 1. That's what I mean. Alright. So at the end of the day, we have arrived at final answer for this question. Now, please check carefully if you can see the board clearly, and you see there I placed some assignments here, and see how to solve them. This is log 30. What you have here is log 30. Log 30 is 16. Then this is minus 2 log 5 over 9 base 10 plus log 400 over 243 base 10. Okay. Then this is log root 35 plus 2 log 1 over 5 minus log 2.5 all in base 10. Then this is log 6 minus log 3 all over log 8 minus log 4 divided by log 5 all over log 0.2. Alright, so if you follow my calculation, I believe you must have got some value, and then we are going to step up home it again. So the next stage of logarithm will be equation in logarithm, which we'll call the logarithmic equation. So get ready for me, prepare yourself. I'm going to expose logarithm greater than what you have now. See you in the next class.